Okay, so introduction to sound. That is our topic now, a concept on waves. Now, as you know, sound waves is a longitudinal wave by nature, meaning that the vibration of wave is parallel to the direction of the wave. So now we want to first of all know what is it that produces sound. For example, when we are talking, we have the vocal cords. The vocal cords produces sound. I'm sure you've heard about a piano playing, a guitar playing. Those are musical instruments. They produce sound. For example, when you rub your feet, your hands against each other, sound is produced. So now what you should know is that for sound to be produced, there must be vibration of particles. Very key concept. Vibration of particles. Then, two, there must be a media, meaning there must be air particles. Now, when you look at this diagram, you see something that appears like this. This is called a tuning fork. I don't know if you've seen it before, but that's it. So now, how does it behave, a tuning fork? So whenever you see it, something like this, sometimes it is being drawn in a book as upright, meaning these will face up. And sorry for the blare there. So what you do is you get this thing and hit it on something. And then when you hit it, you try to put it in water. So what happens is the water splashes. Now, that tells you that sound really vibrate. So it's because of the vibration that splashes the water. So that's what you should know. Now, when the sound is being produced, what happens is it disturbs the air particles. And when it disturbs the air particles, there are two things that are being formed. There's what is called a region, which is compression, and the region, which is a rarefaction. So two regions will be produced when you disturb the air particles. You produce sound, that sound disturbs the air particles. And when it goes through the air, it creates two regions. Now, what do we mean when we say compression? Look at this diagram. This part shows that here it's a region of higher air particles because these things, they are close to each other. So the area where their particles are very far from each other is called the rarefaction. So this is a compression, this is a compression, but this part, and this part is a rarefaction. Why? Because they are lower air particles, but this part has higher air particles. So this is what you should know, what happens when sound travels in the air. These are the two regions that it creates. So that's what you should know about a sound wave. Now, about sound wave, again, you should know that sound wave requires a medium for transmission. And how can you do that experiment? It's a simple experiment that can be done. So what you are seeing here is just a simple bell, an electric bell. Okay? What you are seeing this side is a vacuum pump. And then what happens inside there is, before you remove the air particles, for example, what they can do is just put a clock inside there. This is a bell jar. So a clock there, it will be ticking when there are particles. You hear something like teh, teh, teh. It means there are air particles. Now, when the air particles are removed using a vacuum pump here, slowly that sound of coming from the clock will be fading. It will be reducing. Teh, 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 teh. When the air particles are being removed from the bell jar here, no sound will be heard. So what does that tell us? Sound requires a medium for transmission. Thank you for watching.